So today we've got an optimization problem. So suppose you're on the bank of a river and need to get to a camp on the other side of the river, 3 miles away from the point directly across from you. The river is half a mile wide. Suppose you can walk at 4 miles per hour and swim at half mile per hour. Where on the other side of the river should you swim to minimize your travel time? Okay, so just like when you're working with maybe like related rate problems in calculus, you draw a picture out. I totally recommend that here. So I drew the river. It's half mile wide. Here's where you are at. Let me just highlight that. And here's the camp. And the idea is you're gonna swim somewhere to the other side. And yeah, so you can swim there, you could be here, swim all the way to the camp if you want. They didn't say you couldn't, or you could, swim straight across. That's up to the person here. But let me do this. I'm gonna, because we're trying to generalize the picture here. The route specifically. Let me say this is a point where you're gonna swim to, and the distance from that point to this point directly across from you is called x. The distance is called x, excuse me. And recall that the whole distance is 3 miles from the point directly across from you to the camp. Therefore, the distance from the point that you land to the camp would be 3 minus x. Okay. Now, we draw a picture and we do that to try to understand, what's going on and form our equations from that as well. Now, for us to do that, we want to first understand what we're trying to minimize, which is the time. And if you think about it, well, time is split up into 2 parts, the time swimming plus the time walking. And I don't have a time for swimming, I don't have a time for walking. And right, that wouldn't be the point, because you would have answered the question already. So what can you do to get an expression perhaps for the time swimming and the time walking? Well, we know that distance is rate times time, or distance over rate equals time, so I can use that. Now, if I were to look at, let's say, the time swimming here, I need to find the distance over the rate, and the distance here, I can use the Pythagorean theorem to get the square root of x squared plus a half squared, which is a fourth. So again, by the Pythagorean theorem, that's what that distance would be. And if you divided it by a half, that whole expression becomes 2 times the square root of x squared plus a fourth. All of that is your time swimming. For your time walking, similarly, the distance would be 3 minus x, because you landed at an x value, x distance miles away from the point across from where you swam to. And the rest of the distance would be 3 minus x. So 3 minus x over 4 is your time of walking, because you have a rate of 4 miles per hour. So, and I had a rate of a half mile per hour for swimming, by the way. I didn't mention that, but that was the case. And therefore, when you add those 2 times, that is your total time. And we have a restriction on x. X can go as little as 0. So you just, that's when I said you can swim across directly to the other side. And you can swim directly all the way there to the camp. And that would be when x is 3 here, okay? So that is a restriction to consider. And we're going to use that in a minute when we try to actually prove our values will minimize our total time. So your time is equal to what's given. If I want to minimize or maximize this with calculus, I'm going to have to take a derivative. So which we just did right here. Well, I did. So you get 2x over the square root of x squared plus a fourth, plus minus a fourth. So combination of chain rule and a little bit of algebra here, by the way. The derivative of that 3 minus x over 4, I split that up, first of all, as 3/4 minus x over 4, or 1/4 x if you prefer. And the derivative of 1/4 x, or minus 1/4 more specifically, is minus a fourth. So I didn't want to use the quotient rule on that. All right, so then what do? We take our derivative, we set it equal to 0, or we also set it to be where it's undefined, but that's not going to happen here, so we're not going to worry about that. But just recall that when we're looking for critical points, you set derivative where it's equal to 0, or where the derivative is undefined but continuous. And that doesn't happen here because your derivative is never undefined. X squared plus a fourth is always positive, that denominator. Right, I'm looking at the denominator because if we had any problems, it'd be with the bottom, the denominator of that fraction. So anyways, let's set that equal to 0 and solve. So I move the 1/4 over right here, and then I cross multiplied and got what you see here. I squared both sides, and then I move all the x squareds over and I divided by 63. And x would equal the square root of 1/4 times 63. Now I didn't multiply 4 and 63 here because I don't think that would give us much. I'm interested in breaking this number down. So 63 is 9 times 7. So this would be 1/4 times 9 times 7 times the square root of that. So the square root of 4 is 2, the square root of 9 is 3. And yeah, moreover, that's why I'm doing this, so I can break this further down. So you get 1/6 root 7. And this was a distance. Recall x was a distance away from the point directly across from you. So 1/6 root 7 miles. And so that's great, but is that going to minimize my time though? Well, we need to actually prove that. And how do I prove that? There's a couple ways of doing it. You can use a number line. That's one way. Or you can also use the extreme value theorem, because we were given a function and a closed interval. And from a little bit of theory, we know that the minimum or maximum is going to happen either at the endpoints or at the points where the derivative equals 0. Okay, so if you plug 0 in, you would get 2 times the square root of 1/2 plus 3/4. Sorry, the square root of 1/4. My apologies. And if you did the math further, that's 1 3/4 or 1.75 hours. If you plug 3 in, you get 2 times the square root of 9 plus 1/4, plus 3 minus 3 is 0, so you get 0 out of that. This becomes 2 times the square root of 37 over 2, essentially, if you do the calculations there. That cancels out, and the square root of 37 hours. So that's like 6 and some change, a little over 6. And if you looked at these numbers, just put them into context, that makes sense because, you know, the T of 3 basically means that you swam all the way to the camp. You never walked, so it's going to take you some time to get there swimming. And then finally, 1/6 root 7 with the power of calculators here. That gives us 1.742, or let me just say 1.74 hours approximately. Okay, so your minimum time happens at 1/6 root 7 miles. Okay, so your point here is going to be 1/6 root 7. Yeah, it's a distance miles away from that point, which was directly across from you. Okay, so that's kind of like a take on an optimization problem. One thing that I wanted to mention is when you're dealing with these problems, let me go back to that part where I set up an equation here. You often will, which is right here, you'll often encounter the part that you're forming at first in terms of 2 variables, okay? And that's just fine. That sometimes will happen. In fact, it's more often the case it's going to be 2 variables. And what you'd have to do is think of what we call a constraint. A constraint is an equation that relates the 2 variables. So you'd have maybe x and y there for your time, to describe your time, but you need to describe time. You would have another equation that relates x and y together. So like x plus y equals 8, something like that. And on that end, you'd have to solve and plug that in. Now, I've made a video of that, and I'll link to that so you can take a look at that more closely. But just be aware of that. And that usually is the hardest part of the problem, is actually forming the equation. The second hardest, I would say, is taking the derivative and setting it and solving it. Actually, the derivative actually isn't that bad. Solving it is a lot. The big thing here with a lot of these problems, it's not easy. So just be aware of that. Just be patient and take your time. All right. Well, thank you so much for your time, and I hope this helps.